points. Okay, so the following SQL creates primary key and ID column when person table is created. Create table name and ID int not null, and first name and last name not null, and age is not null, and primary key is ID. They declared as primary key. This is in MySQL. They will return like this, or how it will return in SQL Server means SQL or Oracle or MS Access directly will declare here only primary key. That is the difference. That's it. So directly create table name, ID int not null, primary key, last name, first name, where is the data type of the last names. Okay. Age int. Okay. Come. So in this way we will declare. So if you remove this not null primary key, if you remove this primary key won't apply to this particular table. So primary key is a combination of unique values plus cannot contain null values. Okay, that is the point. Okay, you don't need to worry. I will explain foreign key. SQL foreign key constraint. So a foreign key is a key used to link two tables together. So how we link that two tables together? We'll see. A foreign key is a field or collection of fields in one table that refers to the primary key in another table. Okay. The table containing the foreign key is called as a child table, and the table containing the candidate key is called referenced or parent table. Candidate key is nothing but so what is that candidate key? So primary key only, right? Okay. See here. Look at the following two tables. This is a person's table. Here person's table, person ID is there, last name is there, and the age is there. Okay. So orders table, come to orders table. In orders table, order ID and order number and person ID is there. So in both tables, what is the common column between two tables? So person ID is the common column, person ID and person ID. So in this table, person ID and person's table, person ID is the common column between two tables. That means relationship column. So now we need to decide which one is the primary key column and which one is the foreign key column. See here, what is the rule? Primary key rule. So unique, it contains a unique values and cannot contain null values. 1, 2, 3 here, 1, 2, 3 unique values come here. 3, 3, 2, 1 here repeating, correct? So simply we can say this is foreign key. How it is foreign key? It is referencing to the another table. What is the difference? What is the definition here? A foreign key is a field or collection of fields in the table that refers to the primary key in the another table. So primary, it is referencing the primary key in this table. Another table is in the sense another. This is a primary key. So this primary key is referencing in another table, orders table here. So how it is referencing, we'll see. See, so here person ID is 3. That means who is that person ID? Patterson. Okay. And first name is Curry and age is 20. Okay. Fine. So here person ID is who is this guy? So we are identifying the information. So based on these IDs, right? 3 means this person. Okay. So same person, he added two things. Curry added two orders. And this guy, second one means Svendanson. Sorry. This second person, this guy, person ID 2. This guy is ordered and this is our first name, and this is the age. Okay, so we are identifying the information. So simply what we can say, what I can conclude is, for example, let's say, for example, instead of 3, if I kept here null, then again I have to keep here 2 times null, correct? So then how to identify? So for example, you have here one null instead of 3. Instead of 1, I have 1 null. So I have, then if I put here 2 nulls, then what will happen? We cannot recognize, correct? So that's the reason why primary key always, it's a combination of unique plus not null values. Okay, fine. And Power BI classes. So I will show one data set. Employee table. So here employee table is there. Here employee table, employee name is there, employee number is there, job is there, manager is there, hire date is there. In this table, which one, employee table and department table, which one is the common column between two tables? So here common column between the two tables is department number. Okay, so department number is the common column between two tables, correct? Department number. See here department number is 10, 20, 30, 40. Okay, here relationship is how it is 10, 20, 30, 40. If you come employee number, department number 20, 30, see here department number is repeating. So here in the department table, department number is the primary key. In employee table, department number is the foreign key. Okay, in this way we can identify. So here repeating, here is not repeating. By seeing the data only you need to recognize. And so detailed explanation of fact table and its steps. Okay, and so in Power BI projects there are two types of schemas. First of all, I have to explain that. So one is a star schema and one is a snowflake schema. So what is star schema, what is snowflake schema, we'll discuss now. Okay, Power BI material. Okay, in star schema, so it contains a fact table, one or more fact table, and surrounding dimension tables. Very simple point. Star schema is nothing but it contains a one or more fact table. It can contain one or more fact table and surrounding dimension tables, and that's it. And so what is fact table contains exactly? So fact table contains, so foreign key relationship with the dimension tables, and whatever we can quantify and whatever we can calculate, those things will be hold. Okay, so for example, fact table in the sense of without fact table we cannot do any calculations in Power BI. Fact table is very important. So first of all, let me explain what is dimension table. In dimension table, it have a primary key. Okay, primary key and description of the product. For example, let's say an example, this is a Mysore sandal soap. Okay, this is a soap. Soap ID is 1. Here one more dimension table is there, and this is a soap. This is another soap. Let's say an example. So for example, this is the soap ID, right? I said. So for example, Damu is came and Damu purchased Mysore sandal soap. Okay, so here ID is 1 and he purchased, all sales details will be maintained here. Okay, so customer name Damu and ID is 1, and Mastan also came. Mastan also took one Mysore sandal soap. Then so ID will be the same, customer name will be the different. So here two times here repeating the data. That's the reason why we have the relay. Let's say an example. For example, Mastan came and he took one Mysore sandal soap and he took one Liril soap. Okay. So Liril ID is two. Okay. One person can take more different kind of soaps, right? It's a possible, right? So like that, what will happen? So so here foreign key will be there. So here data, so all customers details and all of customer sales details will be here. Okay, that's all orders details will be maintained in the fact table. That's the reason why it is called fact table. Okay, in the fact table it contains a foreign key relationship with the dimension tables and whatever you can contain. So for example, how much sales quantity happened, what is the product quantity, what is the amount sold, what is the average sales, all those things will be maintained in the fact table. So by seeing the relationship only, we can easily recognize what is fact table and what is dimension table. Okay, so in dimension, for example, take a soap, right? I said soap, right? This ID is one. Okay, so for soap, one color will be there and weight will be there and price will be there and discount will be there. Those things will be available in dimension tables. Okay, based on so generally we filter the data from dimension table to fact table. So this is nothing but star schema. Star schema can have more than one fact table and surrounding dimension tables. That's it. And snowflake schema. Snowflake schema is containing one or more fact tables. And so what is snowflakes means? It can have one or more fact tables. Same like star schema. Mm, and the surrounding dimension tables. These dimension tables contain again a dimension. Subdimension is called a snowflake. Mm. Snowflake schema contain one or more fact tables and dimension tables and it contain at least one subdimension table. If it is contain one subdimension table, then it is called a snowflake schema. Okay, here data is snowflaking. So here data will be normalized the data. So very only one difference. So here data will be here dimension here data will be derived into another subdimension table. Okay, and now and one more important question: what is fact table and types of facts and fact table types? Okay, this is important to understand for implementing projects and also important for interview point of view. Okay, that's the reason why I added here. So what is fact table? A fact table holds the measures and metrics, other quantifiable information. For example, sales quantity. Okay, best example. So here you need to observe these things. Types of facts is different and fact table types are different. Okay, types of facts is different. There are three types of facts. Facts are different. Okay, additive facts, semi-additive facts, and non-additive facts. What is additive facts? Additive facts can be used with any aggregation functions like sum, average, etc. Example is quantity, sales amount. You take any aggregation. Additive facts means it will support all aggregation functions. Very simple. Additive facts means it will supports all aggregation functions. For example, you take quantity. We can do sum of quantity, right? We can do average of quantity. We can do minimum quantity. We can find maximum quantity. We can find average, minimum, sum, mean, median, whatever we have. We can do it, right? And all it will supports all aggregation functions. If it is supports all aggregation functions, then it is called additive facts. And semi additive facts. What is semi additive facts? Semi additive facts are those where only a few aggregation function can be applied. So semi-additive facts. So we cannot apply all aggregation functions to the semi-additive facts. For example, consider bank details. You cannot apply sum on bank balance. That does not give useful result, but minimum maximum function may return useful information. Okay. So take an example. You have some balance. Okay. For example, in your bank, you have some 10,000 rupees. So if you do some, it will give exact result. It will give useful result. So 1 plus 0 plus 0 plus 0 plus equal to what happened? It will give 1 only, right? So here some function we cannot apply. So if you apply also, it will work, but it won't give the useful result. That's the reason why here some function is failure. But you can use minimum, but we can find out the what is the minimum transaction we done, and what is the maximum transaction we have done, and what is the average transaction we have, what is the average balance we maintained in the account. Those things, those calculations may be useful. Those calculations it will support, and those calculations will be useful. So here some function is absolutely failure. That's the reason why they are calling here additive facts. This is, so you can take an example, bank balance, semi additive facts. So only here it is supporting only few aggregation functions, and few aggregation functions not supporting. In the name itself it is there, semi additive facts and non-additive facts. In the name itself it is there. You cannot use numeric aggregation functions such as sum, average, etc. Non-additive facts. For example, non-additive fact is any kind of ratio or percentage. See, you cannot use numeric aggregation functions such sum, average, and and non-additive facts. Okay, fine. You cannot apply any aggregation functions, any numeric aggregation functions on these facts. For example, non-additive fact is any kind of ratio or percentage. You cannot apply sum, average, and ratio or percentage. We cannot apply, right? So that's the reason why non-numeric facts also be non-additive facts. So we can say non-numeric facts or non-additive facts also we can carry. So three types of facts. So one is additive fact, and semi-additive, and non-additive. Additive means it will support all aggregations. Semi-additive means it will support only few aggregations. So for additive facts, you can say quantity and sales amount, and for semi-additive, we can say minimum maximum. Okay, so sorry, bank balance. Okay, bank balance, it will work for a minimum maximum, it won't work for the sum bank, okay, on the bank balance. And non-additive facts, for non-additive facts it won't support aggregation functions like sum, average, whatever, okay, minimum, maximum, all those things. Best example, ratio or percentage you can tell. Now it will come to types of fact tables. What? Okay, types of fact tables are some different. So types of fact tables means there are 5 types of fact tables are available. So first one is factless fact table. Fact, in the name itself it is there, factless fact table. A fact table that does not contain any measure is a factless fact table. This table will only contain keys from the different dimension tables. This often used to resolve many-to-many cardinality issue. Okay, factless fact table is, so what is fact table? What I said, in the fact table it contains the information. Calm down. It contains the foreign key relationship with the dimension tables, and it contains the information quantity sold and amount sold and average sales. Okay, so it contains this information. Okay, so here what are the facts here? Here quantity is the fact, and amount is the fact, and average sales is the fact. So if you don't contain these things, if you don't contain these things, quantity, sales, amount, average sales, if you don't contain these things, this is called as facts. If you don't contain these things, it will be called as factless fact table. Only it contains a relationship with the dimension tables. Relationship with the dimension tables. If it is contain only relationship with the dimension tables, then it is called as factless fact table. Next, second one is centipede fact table. What is centipede fact table? Centipede fact table is a normalized fact table. Modeler may decide to normalize the fact instead of snowflaking dimension tables. Okay. Centipede fact table is a normalized fact table. What is normalized fact table? There is a concept normalization in SQL Server. So simply I will tell you. See here. Here data employee. This is the employee table. This is the department table. Here employee number is there, employee name is there, job manager, hire date, and salary column is there, and commission is there. And if you come here, department number is there, and here department number is there. So if you don't have this department number so this department number is intentionally created. Why I tell you? Okay. So if you don't have this department number, directly we can write these things, right? Department name and location. So if you don't have a common column between two tables, then what we need to do? Then definitely we need to write this department name and department location here. So if you have the data here only without department number, department name and location here. So data will be like this only, department name and location. What we do is data modelers, what they do is in every company, data modeling team will be there. They will take care of you. You don't need to do everything. You don't need to worry everything. So you just know how to use the Power BI desktop. That's it. How to prepare the reports into the Power BI desktop and how to publish the reports into the Power BI service. That's it. Nothing more than from your end. You are a front-end developer. Okay. So but for clarification, I am telling you. So data will be like this only. Here department name and location will be there. Intentionally they created a common column between two tables. Why? Means I will tell you. For example, here only 15 records are there. Okay, that's fine. Only 15 records are there. That's fine. Okay. And I want to uh, see, for example, here 15 records. For example, say let's say an example. If you have here 1 million records, then if you have the columns, department and location, you need to write 1 million times here department name and location. Correct. So you cannot filter the data. If you want to filter based on the table, department number or something, you cannot filter. So if you, what they do is, data modelers, what they do is they intentionally create a common column between two tables and they divided the data. So now here while they're dividing, they create a relationship between two tables. How they will divide means they will create a common column between two tables. What is the common column here? Department number and department number. So here this is the foreign key column, this is the primary key column. Here they take unique numbers 1, 10, 20, 30, 40, department name and location. It doesn't matter now here 1 million records and 1,000 million records. Okay, it doesn't matter. So here in what is the advanced means, here we are reducing redundancy of the data. We are reducing redundancy of the data, and performance wise also it will be very useful if you divide as two tables. If you divide as a two, instead of maintaining one big table, if you maintain relationship between two tables, and if you divide into two tables, then the performance wise also good, and then data can be, we can filter from dimension table to fact table. And so there are some performance issues, performance improvement also will be there. So what they are trying to tell is, in centipede fact tables, so data will be normalized. That means data will be divided like employee table and dimension table. Okay. If it is not divided, if it is normalized means, so these two columns, this department name and location also should be here, should be in the same table. If all information in the same table, then it is called a denormalization. If it is divided into two tables, then it is called as normalization. That is simply, okay, remember this point. So that's what they are trying. Okay, so here centipede fact table contain, centipede fact table is a normalized fact table. Okay, it's a normalized fact table. So first one is factless fact table. In the factless fact table, we don't have facts. That means we don't have any information like username, sorry, quantity, price, and sales amount. Those things it doesn't have. Okay. For example, a fact table which has only product identity date case is a factless fact table, only having relationship here. Only this is the dimension table. This is the fact table, only having relationship between two tables, but it doesn't have any containing measures. And conformed fact table. Third one is conformed fact tables. What is the conformed fact tables? They are measures reused across the multiple dimension models. Okay, for example, KPI such as profit and revenue. So conformed fact tables is nothing but so here the information is confirmed. For example, in the fact table we have, this is the fact table, right? So we have foreign key with the dimension tables, and we have here amount, quantity is there, and sales is there, and average sales is there. This is fine. But if we have here profit and what is that? Yeah, profit and revenue. If you have profit or revenue columns, then it is a confirmed, because we don't need to calculate, right? So already it is giving profit, how much profit. So we don't need to calculate it, whether it is loss or whether it is gaining and all. So already we have confirmed information. If you have the confirmed profit is the confirmed information, right? Profit or loss will be the confirmed information. That's the reason they called as conformed fact tables. Conformed fact tables. And fourth one is incident and snapshot fact tables. A fact table stores some kind of measurements and are captured against a specific time. Now it might so happen that the business might not able to capture all of its measures always for every point in time. Then those unavailable measures can be kept empty, null. Okay, can be filled up with the last available measurements. The first case is example incident fact, and the second one is the example of snapshot. Okay, so what they are trying to tell is whenever we are maintaining the some data, for example, take some any uh, any retail, any you take any DMart or something, any supermarket you take, for example, the supermarket people are maintaining some data, right? So everybody, every customer's data they will maintain, right? Every product data and every customer's data they will maintain in the store. Okay, while maintaining the data, for example, they're maintaining the data about the customer, maybe they don't have some information. Okay, maybe they don't have some information. That information kept as null is called as incident. So can be filled with can be filled up with the last available measurements. So they will fill whatever the information having about that in that particular person or product, they will be fill the information about later. First initially they will keep it as a null, and they will fill whatever the information based on available information, they will fill with the uh, fill it with the data. Okay, so then the first case is of incident fact, and the second one is the example of snapshot. That is nothing but snapshot. Whenever we fill na, that is nothing but the snapshot. So whatever the available measurements, we'll fill it with the last available measurements. Okay, so that's the reason why it is called as incident and snapshot. Incidents means when while maintaining the data, whenever we don't have the whatever the information we don't have about that particular customer or something, then order or something, then we'll just mention null. So whatever the information you have available, Based on that, you will fill that null values. That is nothing but snapshot. So incident and snapshot fact tables will called. And the last final one is cumulative fact. In the name itself, it is there. What is cumulative? This type of fact table describes what has happened over a period of time. For example, this fact table may describe the total sales by product and by store and the day. Okay. So for example, you joined in some company. Okay. So in every financial year they will provide some hikes, right? So how they will give the hikes? They will see the they will analyze your performance. How they will analyze the information? So employee name by, so they will check yearly performance, quarterly performance, and monthly performance, and semester performance, and then based on that they will give the hikes, right? Correct. So for example, you have in your fact table you have detailed information. How total sales, see here, total sales by product. If you have only total sales by product, then it is normal fact table. uh, Here what is there? Total sales by product, by store, by day, by month, by year, or something. If you have detailed information, cumulative information, then it is called as a cumulative fact. So if you have detailed information, then it is called cumulative. Cumulative is nothing but detailed only, right? Okay. So that is what we do. So this is the fact table and its types. Okay. So fact types of facts are three types: additive, semi-additive, non-additive. And fact table types are five types: and factless fact table, and centipede fact table, and conformed fact table, incident and snapshot fact table, and cumulative fact table. And dimension table, already you know, dimension table contain description of the product. Okay, it contains a primary key relationship with the table. Okay, it contains a primary dimension table is nothing but it contains a primary key and description of the product. Simple. Fact table can contain a foreign key relation. Here primary key means here foreign key. So here foreign because here sales details will be there, right? So here fact table contain foreign key relationship with the dimension tables, and whatever we can quantify, whatever we can calculate, those things will be available here in the fact table. So in star schema, so one fact table and surrounding dimension table. If we have one more sub dimension, then it is called snowflake schema. Okay. For example, this is the fact table. This is a dimension table. This is a dimension table. Here again we have one more dimension table. So now it is called snowflake. If you don't have this, then it is called fact table. Okay. Star schema, sorry. If you don't have this dimension to sub-dimension, then it is called star schema. Otherwise, it is called snow flake, snowflake schema. Okay. Now I will show the some data. You need to recognize. Okay. First of all, let me go to let me cross check. So if I am anything missing, can say star schema and snowflake schema in Power BI. So this is the official document. Understand star schema and importance of Power BI. Come here. So understand star schema and importance of Power BI. Star schema is a mature modeling approach widely adopted by relational database warehousing tool. Okay. So here in star schema, there is a fact table and surrounding dimension tables. Star schema relevance to Power BI models. Star schema design and many related concepts introduced in. Okay, calm down. Dimension tables are support filtering and grouping. Okay. So here dimension tables are there, right? This dimension table supports filtering and grouping. Why use in Power BI means this dimension tables used to filtering and grouping. We can group the columns. We can group the for example, we can take one column from dimension table and one column from this dimension table and one based on, we can group these two dimensions and we can calculate based on this fact table. Okay, we'll club with the fact table and we'll calculate. Okay, and fact table supports summarization. Summarizations means we'll do the things, and here it will be many to one relationship. Already I told you, right? In dimension table, what it will be, the primary key. Dimension tables having primary key, and in fact table we have foreign key. That's the reason why this star is nothing but many. This is one, this is many. See here, snowflake dimensions. Here fact table is there. Here one fact table is there. Dimension dim product is there, and a dim product subcategory is there, and dim product category is there. So if we have only fact table and dim product, then it is called a star schema. This dimension table again containing a subdimension. That's the reason why we are called as snowflake schema. See here, we have fact table and we have dimension table. Now that's the reason why we call it as this is star schema. Here data is snowflaking. That's the reason why it is called as snowflake schema. I said you right in previous class. So we have only one primary key column and we can have more than one primary key columns. In one table, only one primary key will be there, and we can have more than one primary key columns, right? Okay. This example also I will clear. So this is something about factless fact table. They given only one table, factless fact table. In the factless fact table, only it contains keys. There is no sales amount, there is no price, there is no quantity, there is no quantify information. That's the reason why they are calling factless fact table. So they given only one, we discussed more. Okay, because maybe those things are important for interview point of view. Those things are important to understand in real time. Okay, fine. I'm connecting to my SQL server. Adventure works. Now see. Anyone guess this is snowflake or star schema? Hello, Damu.
No, I can't tell.
Ramesh, you can't
Yeah.
tell?
Snowflake.
Hello?
Yeah. Tell me,
Yeah.
Ramesh. So this is snowflake schema or star schema? It comes under.
Snowflake schema.
Yes, absolutely. How?
It is divided into the subcategories.
Yes, absolutely. Correct. Awesome. See here. Here, fact tables, these are the fact tables, fact reseller sales and fact. These are the, it doesn't matter how many fact tables you have. For star schema also, you can have multiple, we can have one or more fact tables. And Snowflake also, we have one or more fact tables. But in Snowflake, what is the difference? In Snowflake, data will be derived in another table. See here, what is here? A dim product is there. Again, dim product category is there. Again, it is derived into dim product subcategory. So that's the reason why. Now I will show you example. So now I will load 1, 2, 3 and fact table, and also I am taking dim date. Okay, now load, import. Now come to relational. Come here. So what I will do is I will make this see here. Here fact table is there, correct? Here one fact table is there, and this side dim date dimension table is there. Here dim product is there. If you have fact table and surrounding dimension tables, then it is called star schema. But this dimension table again containing, see here, this dimension table again containing two subdimensions. That's the reason why it is called as, now we can, snowflake schema. Here data is snowflaking. That means I said right in just before only I said here data is normalized. What is normalized means this is the perfect example. Dim product. This dim product is divided into dim product subcategory. This subcategory divided into the dim product category. So here here data is normalized. So if it is data is normalized, then what schema? This is snowflake schema. If data is normalized, if this subdimension subcategory and category also in the same table, then it will be star schema. So now I am deleting, delete from model. Can delete here also. So now we have only one fact table and only we have two surroundings tables. Okay, so in this way we need to recognize. So basically AdventureWorks is Snowflake schema. Okay, so this is about today's class. So if you have any questions, any confusions, please ask me. This is